Magandang araw sa iyo na nanonood ng video na ito. Sana ay nasa mabuti kang kalagayan. Ngayon, pag-uusapan natin ang mga topic na maaaring magamit as you go along with the subject, logic, circuits, and switching theory. Una dyan ang
close up mo ba?
number conversion. Sa number conversion, Sa number conversions, we are going to change a certain number in this base to another one. Kasi hindi lang decimal ang base na meron tayo. We have kasama ng decimal, which is in base 10, na composed of 0, 1, 2, hanggang 9. We also have this binary, which is in base 2, composed of the digits 0 and 1. O diba, dalawa lang sila? Sana all dalawa lang. Also, we have this octal, which is in base 8, and the digits 0, 1, hanggang 7. Also, we have this hexadecimal. Sa hexadecimal, ito na yung base na lampas sa 10. Base. In particular, it is on the base 16. Okay, paano ba to? Having the digits, the well-known decimal digits 0 to 9, including 6 other digits, A, B, C, D, E, and F. Nasanay tayo sa algebra na ito ay variables, but in this number conversion, it is considered as digits. Kumbaga, number din sila. So, paano yan sa conversion? Ganito. This is the decimal number. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Tuloy natin hanggang 15. Ang binary conversion ng 0 ay 0, ang 1 is 1, this 1, 0. This is not being read as 10 but instead 1, 0 kasi nga 2 digits lang yung nag-ECE sa binary. So 1, 0 to 1, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0. O diba 1, 1, sana all marunong mag 1, 1. 1, 1, 1, 1, 0, 0, 0, 1, 0, 0, 1, and it follows hanggang eto. There. For the octal, we have this 0, 1, 2, 3, 4, 5, 6, hanggang 7, and next to 7 is hindi 8. Kumbaga, lulukso ka to 10. 10. 11, 12, 13, 14, 17. For the hexadecimal, eto na yon. 0, 1, 2, 3, 4, 5. It goes along until No, not this one, sorry. A, B, C, D, E, and F. So, to make you understand more about this number conversion, here is one example. We have this hexadecimal number B for 1 point A 1 E A B16. Familiar. To convert this one, pwede nating unahin yung decimal, pwede rin yung binary. So, ano bang dapat nating unahin? Yung decimal ba o yung binary? Okay. Ang dapat nating unahin ay ang ating sarili. Just kidding. Kidding aside, let's try na uunahin yung binary. Sa kadahilan ng pag nahanap na natin yung binary, surprise! Susunod na yung octal. Then sa dulo na lamang po yung decimal. So, okay. Converting this hexadecimal number into binary, we will have, kasya ba? Let's try. For B, we have 1011. For 4, we have 0100. For 1, 0001, and it goes along here. 1010, 0001, 1110, and 1010 base 2. As simple as that. Sana all simple. But as you see naman, the rightmost digit ends with 0, so pwede na natin siyang i-drop. Take note, yung number lang po yung i-drop ha, guys. Hindi po yung subject, okay? So we have 1011, 1.1010, 0001, 1110, 101 base 2. And this is its binary equivalent. O, di ba ang ganda? So, lalagyan natin ng label. Kasi, we all know that having label is very important. Next, gaya nga ng sabi ko, after binary, we will have this octal. Sa octal, we will partition this long thread of digits into 3. For the left part of the decimal point, we will start from the right. So we have 001, this one, 000, this one, 101, this one, and so we already partition it into 3. For the right of the decimal point, we will start from the left. We have 101, 000, 0001, 110. Okay, let's count. Okay, perfect. Everything fits in place. So, in converting this one into its octal equivalent, we will take the value of this one. 101 is 5. 101 is 5. 000 is 0. 001 is 1 point. 101 is 5. Yes, I'm doing the right thing, yes. 000 is 0. 011 is 3. 110 is 6. and 101 is 5. Finally, base 8. Now, we have this octal. Finally, we will convert this into the original number. Yung number na nakasanayan na natin. Decimal. Yes, so we will take this one. B41.A1EA. Let's put some numbers here. We'll count to the left. Starting from 0, 1, 2. And for this one to the right, we will have negative 1, negative 2, negative 3, and negative 4. So, ano meron dito? This will be the exponent of our base 16. So, proceeding, we will have B times 16 to the 2 plus 4 times 16 to the 1 plus 1 times 16 to the 0 plus A times 16 to the negative 1 plus 1 times 16 to the negative 2 plus E times 16 to the negative 3 plus A times 16 to the negative 4. Again, these well-known alphabets are not alphabets. They are not variables, but instead they represent digits. So we will have, for B, its decimal is 11. So 11 times this thing plus 4, copy paste, plus 1, plus A is 10. Plus, okay, so kailangan nating hatiin, plus E, which is 14, plus A, once again, 10, okay. Then, for this one, all we have to do is, we will use a calculator for this one. To simplify this thing, so we will have 11 times 16 squared. Okay, 11 times 16 squared plus 4 times 16 to the 1 plus 1 times 16 to the 0 and tuloy lang 16 to the negative 1 plus 1 times 16 to the negative 2. Hindi ko na-type yung negative. Ninibago ko sa calculator ko, sorry. 14 times 16 to the negative. Negative 3 plus 10 times 16 to the negative 4. And finally, okay, boom! We have 63247 base 10. Of course, this is just the approximation kasi obvious naman na napakaraming decimal point nito. Itong dulo na to. This is just an approximation. So, yes. And that's all for number conversion. Okay, ngayon tapos na tayo sa ating first topic. And for the next one, we have this Arithmetic Operations. For this Arithmetic Operations, ang ipapakita ko lamang sa video na ito ay dalawa. Named as yung ano nga ba yun? we have the using 2's complement. And we also have the Bcd Addition. Okay, so let's proceed with examples. For the first one, here we go. Let's say that I want to add the two binary numbers 1 0 0 1 1 0 1 1 1 0.0001011, or instead of adding let's subtract rather, sorry for the term, okay, subtracting 0, okay, 1 0 0 1 1 0 1 1 1 0.0001011 2 1 0 0 0 1 0 1 0 1 point 1 0 0 1 1 oh sorry 1 0 0 1 1 0 0, both in base 2 binary. So in the rules of mathematics, we have this A minus B equivalent to A added by the negative B. So let's take the negative version of this one using 2's complement. Okay? Take the negative. In taking the negative value of a certain binary number, we will have to use 2's complement. So 1 0 0 0 1 0 1 0 1 point 1 0 0 1 1 0 0. In taking the 2's complement, we will first take its 1's complement, wherein we will take the complement of each digits of this one. So it will become what? Like this. 1's complement. 1 will become 0, 0 will become 1, and it will happen, everything follows. 1, 1, 0, 1, 0, wait. 1, 0, 0, 1, 1, 0, 0, 1. For the 2's complement, we will add 1 to the rightmost digit, not in the units digit, but in the rightmost, no matter what place value it is. So we will have 1 plus 1 is 1 0, carry 1. 1 plus 1, 1 0, carry 1, 1, then 0, 1, 1, 0, point. Okay, base 2. By using 2's complement, this is the negative value of this number. Applying this rule, we will have 1 0 0 1 1 0 1 1 1 point 0 0 0 1 0 1 1 added by the negative of this one, which is again this 0 1 1 1 0 1 0 1 0 point 0 1 1 0 1 0 0 base 2, which is 01011 added by 0111 01010.0110100. Adding, we will have 1 plus 0, 1, 1, 1, 1, 1, 1, 0 point 1, 0, 0, carry 1, 0, carry 1, 0, carry 1, 1, carry 1, 0, carry 1, 1. So, in the given, we have 16 bits here and 16 bits also here. But in the answer, we will have 17 bits. Pero 16 lamang po yung i-accommodate natin. So, this what you call this leftover one will be omitted, and we will take this as our final answer. So, we will have 0.001111111, or by using the rules of significant digits, I think we can safely draft this. So we will have 10001.0111111. How many ones? This one. Okay, this is our final answer. So, in order for us to test if our answer is correct, let's try converting these numbers into its decimal, then let's compare. Oops. Okay, checking. The decimal equivalent of this one is 1, 2, 0, 1, 2, 3, 4, 5, 6, 7, 8 to 56 plus 8, 64, 32, 16, 8, 4, 2, 1, 1 half, 1 fourth, 1 8, 1 16, 164, 128. For this one, we have 311.0859375 base 10. For this one, the original one, we will take the original one. We will have, okay, this is 256, 1, 8, 64, 32, 16, 4, 1, 1 half, 1 fourth, 1 8, 1 16, 1 32, 1 32nd, whatever, 1 over 32, 277.59375. Okay, 0, 0. Subtracting, we will have 311.0859375 minus 277.5937500. We will have 33.4921875 Now, for the last one, we will check if the decimal value of this one is equivalent to this one. So, we have 1, 2, 3, 4, 5. So, 5, 32, plus 1, plus 1 half, 1 fourth, 1 8, 1 over 16, 4, 8, 16, 1 over 32, 1 over 64, 1 over 128, and 33.4921875 base 10. And there you have it. They are similar. So, from this, we can say that our answer is correct. So, okay. we're done with the 2's complement. So now let's have the BCD addition. Let's try adding this. Okay, before we will try to add two numbers. Okay, sorry. I just want to emphasize that BCD is actually a set of what you call this 4-digit binary numbers. Each decimal digit is represented by a 4-digit binary number. That's why it's called BCD, and BCD means binary coded decimal. Okay, converting, we will have the decimal number and its equivalent BCD, equivalent binary coded digit. For 0, we will have 0, 0, 0, 0. 1, we have 0, 0, 0, 1. 2, we have 0, 0, 1, 0. 3, we have 0, 0, 1, 1. I want to use 1, 1. 4, we have 0, 1, 0, 0. 5, we have 0, 1, 0, 1. 6, we have 0, 1, 1, 0. For 7, we have 0, 1, 1, 1. For 8, we have 1, 0, 0, 0. And for 9, we have 1, 0, 0, 1. So question, how can we represent 10? Take note that 10 has 2 digits. We have 1 and 0. For 10, its binary coded, its BCD is, we will take this 0, 0, 0, 1 and this one. BCD. BCD is obviously different to binary, because in binary we all know that the value of this number 1, 0, 0, 0, 0 is 32, but in BCD it is 0, 0, 0, 1, 0, 0, 0, 0, which is 10. Sorry. BCD, base 2, base 10, base 10. Okay. Obviously, a large difference. So, let's try to add two BCD numbers. We have this 0, 0, 0, 1, 0, 0, 1, 1, 0, 1, 1, 1, point 0, 0, 0, 1, 0, 1, 1, 0, added by 0, 0, 0, 1, 0, 0, 0, 1. Okay, sorry for my penmanship. Okay. 1, 0, 1, 0, 1, point 1, 0, 0, 1, 1, 0, 0, 0, BCD. Let's put a label BCD because, like what I've said earlier, BCD is different from base 2 binary. Okay? Okay. In adding this, it's just like, it is similar to adding binary numbers. As you notice, I separated it into I separated the whole thing into sets of 4-digit numbers. Sinadya kong lagyan ng space para maintindihan natin. Parang sa love, kailangan nyo ng space para magkaintindihan. So, let's proceed to adding. We will have 0 added by 0, 0. 1 plus 0, 1. 1 plus 0, 1. 0 plus 1, 1. 1 plus 1. It's not 10, but 1, 0. 0 carry 1. 1. 1. 1. 0 carry. Oh, it's not 6. 0 carry 1. 0 carry 1, 1 carry 1, 1, 0 carry 1, 0 carry 1, 1, 0, 0 carry 1. Am I doing it right? Am I doing it right? Okay. I guess I'm doing it right. Okay. 1. Oh, sorry. Wala yan. 0, 0. And we have it. But we're not done yet because as you see, there are some 4-digit, there are some set of 4-digit numbers here that are, they are not existing in this table. So, if ever that happens, we will add this number 0110 to that particular set of 4-digit numbers. Okay, so 0010 is nandito, 0100 is nandito, 1100 is wala dyan, so we will add 1110 is wala rin dyan, 0110. Then this one is, di ba ito din yun, so wala din dyan. Pero ako, palaging nandyan para sa'yo. Again, adding these numbers, we will have 0, 0 carry 1, 1 carry 1, 0 carry 1, 1, 0. Am I doing it right? I guess 1, 1 carry 1, 0 carry 1, 1, 1, 0 carry 1, 0 carry 1. Whew! 1, 0, 1, 0, 0, 1, 0, 0. Oh, I made a mistake here. I'm so sorry. We will have 1 plus 1 is 1, 0. So, 1. 0 plus 0 is actually 0. I'm so sorry for that. And I guess it doesn't affect the others. So re-adding this one, we will have 1 plus 0 plus 1. 0. Carry 1, 0, and... Okay, now it's already correct. So, we have this as our final answer. For this one, we will not drop the digits because we must maintain the set of 4-digit numbers. We must maintain. Sana all na may maintain. Yes. 0, 1, 0, 1, 0, 0, 1, 1, 0, 0, 0, 1, 0, 1, 0, 0, B, C, D. Okay, let's do some checking. Let's convert each addends and the sum to decimal. We have this one. We have okay, the shadow. Okay, we have 1, 3, 7.16 base 10 added by 1, 5 point, what's this, 9, 8 base 10. Adding this one, we have 4 carry 1, 1 carry 1, 13 carry 1, 5 to
10.
okay. Now let's check if the decimal equivalent of this one is this one. Okay, converting, we have, are they equal? 2, 5, 3.14, and yes, they are equal. So our answer is correct. And finally, for the third and last topic, we have this Boolean function simplification. Simplification. Okay. For this one, we have to use the rules in Boolean algebra. And these rules we will explain it one by one as we go along in solving one problem. In this problem, we are being asked to simplify the Boolean function, y is equals to a, b, c, d, e prime, or a, b, c prime, d, e, or a prime, b, c, d, e prime, excuse me, or a prime, b, c, d prime, e prime, or a prime, b, c prime, d, e prime, or, now, where am I now? A prime, b, c prime, d prime, e, or a prime, b, c prime, d prime, e prime, or a prime, b prime, c, d prime, e prime, or a prime, b prime, c prime, d prime, e. As you notice, I said this one as or instead of plus. So, in simplifying this, let's incorporate some concepts in algebra, but not literally algebra, the usual algebra. I know probably some of us here is very much, very much familiar with the concept of factoring the common monomial. But the thing that we will do is not exactly factoring, but we will do the inverse of the distributive property. Where can I write this one? Probably here. The distributive property is A or quantity B and C. Oh no, not that one, sorry. A and B or C is equals to A and B or A and C. It looks like the normal distributive property in algebra. We will, when you A times B added by A times C. But again, this is not multiplication. It represents n. So let's try. Observing this, it will probably take you a long time, but the first thing that I've noticed is the is we have this one in common to 4 of our terms. We have this a prime b e prime, a prime b e prime. Where? Here a. Oh, sorry, not here. I'm so sorry. A prime b e prime. Saan pa ba? Not here. And here. Applying the inverse of this distributive property, we will have, okay, not inverse, sorry, but the converse statement of this distributive property, we will have a prime b e prime, or it's just like the same as factoring, but can we consider it as similar? I think no. But here we are, okay? We have this. In this term, we will left with CD. Not the one which plays music. CD. Or CD prime, or C prime D, or C prime D prime. Also, I noticed that the wait a minute. We have this in common. The what you call this? The A prime C prime D prime E term. A prime C prime. Again, using the converse statement of the distributive property, we will have, for these terms, we will have A prime C prime D prime E, and the quantity of B C prime or B prime C prime. Am I doing it right? Okay, I'm so sorry, nalabas na pala yung C prime. Okay, this one, B plus B prime. So, hindi rin natin dapat kalimutan yung other terms. Tulad ko, hindi kita kinakalimutan. Okay, or A, B, C, D, E prime, or A, B, C prime, D, E. Check. We will label it para, or this one, A prime B C, A prime B prime C, D prime E prime. Next thing, for this one, it's pretty obvious na meron tayong mailalabas na common. So, we will have this and this. So, A prime B E prime, and C is being taken out. C and quantity D or D prime, or C prime and the quantity of D or D prime. Or, okay, for this one, we have this, inside the parenthesis, we have B plus B prime. It is a very known property on the category or that when B or B complement is being operated, B or B complement, the result is always 1. The result is always 1. So, we have, for this one, we have A prime, C prime, D prime, E, and 1, or A, B, C, D, E prime, or A, B, C prime, D, E, or A prime, B prime, C, D prime, E prime. Next thing to do is, for this one, we can obviously apply the same rule here. So, we will have A prime, B, E prime, or, and, I'm so sorry, C and 1, or C prime and 1, it's not I, it's 1, or, okay, for this one, it is a known property from the N category that A and 1 is always equals to A. So, this term will stay. A prime, C prime, D prime, E, or A, B, C, D, E prime, or A, B, C prime, D, E, or A prime, B prime, C, D prime, E prime. Okay, next we will have Y is equals to, still following this property, we will have A prime, B, E prime, and C or C prime, or A prime, C prime, D prime, E, or A, B, C, D, E prime, or, am I omitting something? I think no. A, B, C prime, D, E, or A prime, B prime, C, D prime, E prime. Still following this rule, we will have Y is equals to A. Okay, copy paste everything. This is 1 and A and 1 is A. So, this term. Okay, this one. Dadating talaga sa point kapag nagsosolve tayo ng Boolean function simplification na sa tingin natin parang hindi na, parang sa tingin natin ito na yung simplified form, pero for this one may mas isi-simplify pa ito. We have this property from the from the OR category that A or A will result to A. So, taking the converse statement of this one, pwede natin sabihin that A is equivalent to A or A. So, pwede nating doblehin yung isa dito at walang magbabago sa mismong function. Sana all hindi magbabago. Okay. Through trial and error, I've come up with ito yung dodoblehin. We will have A prime B at positioning sa mga compatible, compatible pairs na masasabi na, tingnan natin compatible pairs, we will have this one, A, B, C, D, E prime, or A, B, C prime, D, E, or this one, E prime, C prime, D prime, E, or A prime, B prime, C, D prime, E prime, or ito nga, sabi ko, ito na yung ika-copy paste. A, B, nasan ako? A prime, B, E prime. Ito, sinadya ko siyang i-pair dito dahil meron silang common terms na BE prime. BE prime, BE prime. Dito naman, tinabi ko tong pangalawang A prime, BE prime dahil similar sila dito. They have the same A prime, E prime, A prime, E prime. So, applying the converse statement of the, what you call this, distributive property, we will have BE prime and A prime or A, B, C, D, E prime or paubos na ang aking ballpen. So, sorry, marker. B, C prime, D, E or A prime, C prime, D prime, E or, okay, this one. A prime, E prime, and B prime, C, D prime, or B. For this one, I will introduce another distributive property. This one. A or the quantity B and C will result to A or B and the quantity of A or C. Kumbaga, ito naman yung na-distribute. Ito, then, ganyan, ganyan. In mathematics, ay, alam naman natin na hindi to totoo, di ba? Hindi naman madidistribute yung plus. But in Boolean algebra, pwede siya. So, dapat alamin natin kung saan pwede at kung saan hindi pwede. At kung hindi kayo pwede. Sorry, mapanakit. Joke lang. Applying the distributive property, we will have B, E prime, and the quantity of, where am I in this earth? Teka lang. Di ba I'm so sorry na ipalabas ko na pala ang B, E prime. Ito na lang yung matitira. I'm so sorry for that. We will have distribute, A prime or A, and A prime or C, and A prime or D. Okay. Or A, B, C prime, D, E. Or A prime, C prime, D prime, E. Or A prime, E prime, and the quantity of B prime or B, and C or B, and B prime or B. We all know that A complement or A will result to 1. And A and 1 will result to the same term. Okay, so for this, we will have B or A prime or A, B, C prime, D, E, or A prime, C prime, D prime, E, or A prime, E prime, and the quantity of C or B and D prime or B. Okay, then applying the converse of the distributive property, particularly this one, we will have BE prime and A prime or the quantity of, okay, what's happening to the pen? C and D or A, B, C prime, D, E or A prime, C prime, D prime, E or A prime, E prime, and quantity of C or D. Okay, I'm sorry. And C and D prime or D. Okay? Now, using distributive property, particularly this one, we will have A prime, B, E prime, or B, C, D, E prime, or A, B, C prime, D, E, or A prime, C prime, D prime, E, or A, C, D prime, E prime, or A prime, B, E prime. And finally, these two are just similar terms, and we all know that A or A is equals to A, so we will have Y is equals to A prime, B, E prime, or B, C, D, E prime, or A, B, C prime, D, E, or A prime, C prime, D prime, E, or A, C, D prime, E prime, and that's it. This is the final simplified form of our Boolean function. Now we have the given original function y is equals to A, B, C, D, E prime, or A, B, C prime, D, E, or A prime, B, C, D, E prime, or A prime, B, C, D prime, E prime, or A prime, B, C prime, D, E prime, or A prime, B, C prime, D prime, E, or A prime, B, C prime, D prime, E prime, or A prime, B prime, C, D prime, E prime, or A prime, B prime, C prime, D prime, E. And we have the simplified form of this one. Y is equals to A prime, B, E prime, or B, C, D, E prime, or A, B, C prime, D, E, or A prime, C prime, D prime, E, or A, C, D prime, E prime. Now, we will, determine the truth table of this function and this function, and compare if they are similar. So, we will assume that this is y sub 1 and this is y sub 2, and we're going to prove that y sub 1 is equals to y sub 2. Okay, let's start. A, B, C, D, E, y sub 1, y sub 2. Here we go. Okay, medyo sumuko na yung pentel pen. Okay. Let's start with the first case, where everything is off. 0, 0, 0, 0, 0. What would be the state of these functions? To determine that, we will solve it. We have y sub 1 is equals to A is 0, and B, C, D, E prime, or let's quantify it para mas makita natin. A, B, C prime, D, E, or A prime, B, C, D, E prime, or A, B, C, D prime, E prime, or A prime, B, C prime, D, E prime, or A prime, B, C prime, D prime, E, or A prime, B, C prime, D prime, E prime, or A prime, B prime, C, D prime, E prime, or A prime, B prime, C prime, D prime, E prime. For y sub 1, we have this is 0, this is also 0, this is 0, 0, 0, 0, 0, 1, 2, 3, 4, 5, 6, 7. This is 0 and this is 0, so we have y sub 1 is 0. For y sub 2, let's also check the state for this one. We will have A prime, B, E prime, or B, C, D, E prime, or A, B, C prime, D, E, or A prime, C prime, D prime, E, or A, C. Okay, I can do this. A, B prime, E prime, y sub 2 is equals to 0, or 0, or 0, or 0, or 0, which means y sub 2 is 0. Now, doing this thing for the 31 other cases, we will have the full truth table of these two functions. And as we see, at all the 32 cases, y1 is similar to y2. With this conclusion, we therefore say that the simplified version of this one is this one. And what we have obtained earlier is correct. So, I hope you learned a lot from this presentation, and if you appreciated it, just click like and share it to your friends. That's all for today. I am Erich Dominic Manginsay, wishing you all the best. See you next time. Bye-bye!